Hello, welcome. Let's look at this simple equation, the calculation for a piston cylinder closed system. A piston cylinder contains 0.90 kilogram of liquid water and 0.1 kg of water vapor at 500 kilopascal when 2000, please, this is 2000, this is not 200, when 2000 kilojoule of heat is added at constant pressure, what is the final temperature and what phases are present? It's very, very simple. A piston cylinder contains 0.9 kilogram liquid water and 0.10 kilogram of water vapor at 500 kilopascal when 2000 kilojoule of heat is added at constant pressure. What is the final temperature and what phases are present? Now, to illustrate this, I use this diagram. This is 0.1 vapor and 0.9 liquid. This is the liquid, this is the vapor, and it has a pressure of 500 kilopascal. Now you add heat of 2000 kilojoule. So this heat that you add now is going to make the temperature to change, and you want to find out this temperature. How do you go about solving this? Remember, the pressure is still 500 kilopascal because it says that it has constant pressure. So you must always draw this moving from this to this. Now, first law of a closed system at constant pressure and using steam table. Those are the two things you need to solve this. You need to code the first law of a closed system at constant pressure, and you need the steam table to solve this. So changing it, internal energy is equal to Q plus W, where Q is heat and W is what? Work. So this is also equal to Q minus, in place of this work, we will put P del V. Now Q can be said to be equal to change in PV. Now, if because of the heat that was added, you can say that enthalpy change is equal to internal energy plus work, which is also del PV. You understand? So this as a whole is equal to Q. So summarily, you can simply say that enthalpy change at this very place minus enthalpy change at this very place, or the enthalpy, the heat content here minus the heat content here, is equal to what was added, which is very, very reasonable, which is 2000 kilojoule. Now, knowing that this is at 2000 kilojoule, from your steam table, I needed to bring steam table so that I will be able to illustrate this very well. Coming. Good. So I just went to get my steam table. Now, from steam table, since this is a mixture of the vapor and liquid, so you can write this to be equal to heat. This H1, actually want to get it so that you can put it here and get H2. H1 is equal to the mass of the mass ratio here of the liquid times its enthalpy plus the mass ratio of the gas that's in its enthalpy. Now, this liquid enthalpy, you can simply get it. You are considering you are looking at steam table at 5 bar. So if you look at this very well, here's the steam table. This first one is called saturated steam table, saturated steam temperature table. That's not the one you want. So this one, saturated steam temperature table, is not the one you want. So you open to the next one. It's also a steam table. So the one that gives you bar, because pressure is what is given and you are looking for the other things, and pressure is 5 bar. So you go and look at it. This is pressure of 5 bar. So if you look up here, you're going to see enthalpy. This is for the solid, and this is for the this for the liquid and this for the vapor. So if you look across this 5 bar, you take it down, you're going to see 640.2 and 2749. So those are the two values, 640.2 and 2749. And that's how we got this 640.2, because we have here 640.2 for the liquid. Then for the gas is 2749, or the vapor 2749. So that's how you got this. 0.9 is already given, 0.1 is already given. So you multiply out and add up, you get 251.1. So that is the H1. So if you now put it back in this equation, H2 is going to be, if you take this over, 2000 plus H1. So H1 plus 2000 is H2. So H2 is going to be 2000 plus this 251.1, and it's going to give you 2851.1. So this 2851.1, you come back to this steam table again and check. If you turn to the next this thing and go to where they have 5 bar, this is the next one. So I'm going to go to where I have 5 bar. It's supercritical, very important, superheated. You must take note of this superheated, because if you look at the heat here is far above what we have here, which is vapor 2749. Here we're having 2851, so you have to take as superheated, and that is what I did here. So I need to get to where I have 5 bar. So this is 5 bar temperature. This is 5 bar. I'm trying to focus this so that you can see it very well. It's not coming up, but actually what is here is 5 bar. So now the enthalpy here alone is 2855, which is close to what we want. So, and if you trace it back, you see that the temperature at that very enthalpy is 200. So that is how they got this. So if you trace this, you're actually going to get 198, which is approximately 200. So that is the temperature you're looking for, which we are told to find. Find the final temperature. And what is the phases? How do you know the phases? The Tsat at 5 bar, if you check from here, the saturated temperature, where you have this and this, is actually 151. So if that is the temperature, that means that at this temperature of 200, which is above, you're going to be having only vapor. So the phases actually present is mostly vapor, because the Tsat is 151.9. But the temperature that you're looking for, the final temperature, is actually 198, which is approximately 200 Celsius. So that's how you go about this. So this is just simple notation of the first law. Then you just simply quote that H2 minus H1 is equal to 2000. Then this is for equilibrium condition of liquid and vapor. So trace this. The one that is F is liquid, the one that is G is vapor in your steam table. So multiply out and add up to get this. Then add this to the heat added to get H2. Then from H2, from the steam table, what you have is to trace back to get the temperature, which will give you 198, which is approximately 200. Thank you. Please, if you like this, hit the subscribe button. If you like our videos, please support us in any way that you can. Thank you. God bless you. If you have any question, drop it on the comment section. Thank you.